we're going to do is we're going to take f of x. So it says let f of x equals 2x plus 1. And then we're going to graph t of x, which is naming the function t, and that's why we call it t of x. But you could call it anything, but just for this one, we're calling it t of x. And what we're doing is we're going to take the original function and we're going to plug in, instead of x, we're going to plug in x minus 3 for the x into the function. Now, we're going to get to that solving in a little bit, but let's not worry about that too much. Let's just go ahead and look at the transformation itself from the table, okay? So if I look at the table, I know that it says f of x minus 3, so I know that's being subtracted there. So it has to be this one here. So that means it's going to, the meaning of that is that you're going to take f of x and you're going to shift it 3 units to the right. Okay, so it says describe the transformation. We're going to do translate 3 units right. Okay, so I'm going to prove that to you guys by actually graphing the parent function. Okay, and then I'm sorry, I'm going to graph the original equation. That's not the parent function. Whew, it's been late. It's a late night. All right, so I'm going to graph that original equation. So 2x plus 1, so that's at b is 1. I'm going to go up 2 to the right 1. And just this is the same equation as our last video. I'm going to draw a line straight across. All right, now that is our f of x. F of x equals 2x plus 1. Okay, that's the blue one. Now, what it's telling you to do is like take your t of x. So in order to get t of x, we're going to take f of x, original function, and shift it 3 units to the right. Okay, so I'm going to actually do that part before I do the calculations and solve it algebraically. So I'm going to go ahead and change my color to red because I'm going to graph t of x. So that means I'm going to take every single point and move it 3 units to the right. So 1, 2, and 3. 1, 2, 3. 1, 2, and 3. 3 units to the right. I'm going to shift the whole thing 3 units to the right. And then we're going to check to see if that's correct when we solve for it. Okay? All right. And that is t of x. So this here is t of x equals f of x minus 3. Let's go ahead and try to solve for that. Like if I was to plug in f of x minus 3, I want to see what happens to that. So I know that f of x is equal to 2x plus 1. In order for me to get t of x, I have to take the original function, but substitute x minus 3 into this one here. So let me just rewrite this so you guys can see. All right, so t of x is equal to me taking the function 2x plus 1, but instead of x, I'm going to actually plug in x minus 3. So this would be t of x equals 2 times the quantity of x minus 3 plus 1. So our equation is t of x equals, distribute, 2x minus 6 plus 1, and then we get t of x equals 2x minus 5. So if I look at the graph, I want to see if I can graph that. My m is 2, my b is negative 5, so I'm just going to check that. So negative 1, negative 2, negative 3, negative 4, negative 5. Hey, there is my y-intercept at negative 5 up 2 over 1. So same graph. So you can see that I'm just solving it to see that, or you can physically kind of like see where it shifts. So t of x is the same. Sorry, that's t, not f. Hey. Okay, t of x is equal to f of x minus 3. When I simplify that and solve that out, I get 2x minus 5. So this graph moved to the right 3 units.